So here is some yeah, you see. Our main aim is it audible to everyone? Is it audible? Is it audible? Is it audible? Hello. Hello. Is it audible? Is it audible? Comment on the comment box. Hello. 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 Is it audible? Is it audible? Hello, hi. This is hello, hi. This is good. Hello, hi. Good evening to all. This is Juhi Miss from Goscore Learning Center. We are the fastest growing ETA company in GCC. Our main aim is to provide education to all. So today you are all eagerly waiting to study organic chemistry, grade 12, chapter 12, aldehyde ketone carboxylic acid. So before moving to our topic, we can go through the syllabus of aldehyde ketone and carboxylic acid. So on moving to our introduction part, first one is the general introduction of aldehyde ketone and carboxylic acid. Then we are moving to the nomenclature of aldehyde ketone and the structure of carbonyl group. Then we are moving to the method of preparation of aldehyde and ketone. Then we are moving to the chemical and physical properties of aldehyde ketones. So after that, after completing aldehyde and ketones, then we are moving to the carboxylic acid and the preparation of carboxylic acid, then chemical and physical properties of carboxylic acid, and last finally the uses of carboxylic acid. So let's begin our topic. First one is general introduction. So what do you mean by carbonyl compound? What are carbonyl compound? Carbon oxygen double bond is called carbonyl compound. What is carbonyl compound? Carbon double bond oxygen is called carbonyl compound. So it has the general formula CnH2n O. What is the general formula of carbonyl compound? CnH2nO. Where N may be 1, 2, 3, etc. So, suppose if the carbonyl group is attached to one end of the carbonyl group is attached to, so this is carbonyl group, carbon containing carbon and double bond is called carbonyl compound. And if the carbonyl group is attached to, this is carbonyl group. If the carbonyl group is attached to an alkyl group and hydrogen, then it is called aldehyde. So then it is called aldehyde. So it is aldehyde. If the carbonyl group is attached to one end of the carbonyl group is attached to OH, then it is called carboxylic acid. Carboxylic acid. If the both end of the carbonyl group is attached to, if the both end of the carbonyl group is attached to an alkyl group, then it is called ketone. Then it is called ketone. So these are the general formula of aldehyde, carboxylic acid, and ketone. I give a simple trick to remember this general formula of this compound, that is hide. Hide means hydrogen. So if it is an aldehyde, there is a hydrogen atom. So hide means hydrogen. Sil, when you all know that when OH group is coming as a prefix, we use hydroxyl. So carboxyl. So you can remember carboxylic acid using sil. So if you are taking, if it is a general formula ketone, how will you remember the general formula ketone? Ketone, to means two. Two alkyl group is attached to the carbonyl group. So like this, you can remember the general formula of this compound. And we have to study some another carbonyl compound, that is if the carbonyl group is attached to, if the carbonyl group is attached to an X is halide group, so it is called acyl halide. It is acyl halide. If the carbonyl group is attached to NH2 group, then it is called amide. Amide. If the carbonyl group is attached to OR, then it is called ester. Then it is called ester. So, if the carbonyl group is attached to C double bond O, C double bond O, R dash. This is acid anhydride. What do you mean by anhydride? There is no water content in that compound. How will you prepare acid anhydride? Just take 2 molecules of acid, that is RC double bond O, OH plus RC double bond OHC double bond OR. Just remove the water molecule from the compound, you will get acid anhydride. What you get? You will get acid anhydride, that is RC double bond O C double bond O R. So this is called acid derivative. Why it is called acid derivative? Actually, we are replacing OH of the acid group, and instead of OH, we are using X NH2 OR OC double bond R. So it is called acid derivative. Is that clear? So these are the general formula of some organic compound that you have to study thoroughly. Okay. On next, we are moving to the nomenclature of aldehyde and ketones. Most of you have a nickname and a real name, is it? You all have a nickname, is it? Like in the same way, organic compound also have two names. That is, one is common name and IUPAC name. So the common name of aldehyde is obtained from So first we are discussing about aldehyde. The common name of aldehyde is derived from the corresponding carboxylic acid, that is the iic acid will be removed as aldehyde. The iic acid will be replaced as aldehyde. The iic acid will be replaced as aldehyde. So I will show. Suppose you all know that when aldehyde or oxidation you will get acid, is it? So this is the aldehyde RCHO. On oxidation you will get acid RCOOH. So this is acid. If we are taking if we are taking the formaldehyde on oxidation you will get corresponding acid, that is formic acid. You will get formic acid. So here the formic acid, it is formic acid. The iic acid will be removed as aldehyde. So the corresponding aldehyde will be formaldehyde. So you will get formaldehyde. Is that clear? Formaldehyde. Another example, if you are taking CH3CHO, you will get the on oxidation you will get CH3COH. What is CH3COH? It is acetic acid. Acetic acid. So replace the iic acid by aldehyde, then you will get the corresponding aldehyde, that is acetaldehyde. Acetaldehyde. Is that clear? So if there is any substituent, in that? Is there any substituent in that carbon atom? The numbering should be given by a Greek letter called alpha, beta, gamma, and delta. So for example for this is CH3, CH2, CH, Br, CH. So in this compound there is a substituent. The numbering of the substituent should be done to the carbon atom adjacent to the CHO groups. That is, the numbering should be started from here. Alpha, beta, and gamma. So alpha bromo, the naming will be alpha bromo butyraldehyde. Alpha bromo butyraldehyde. Alpha bromo butyraldehyde. So the another example for this is CH3, CH2, CH2, CH, Cl, CHO. So this is alpha, beta, gamma. So alpha chloro, you will obtain alpha chloro, gamma bromo. How many carbon atoms? 1, 2, 3, 4, 5, 6. So it is hexane aldehyde. Is that clear? Is that clear for you? Okay, or moving to the nomenclature. IUPAC nomenclature of aldehyde you will obtain in aldehyde. It can be classified into 3: simple aldehyde, alicyclic aldehyde, and aromatic aldehyde. So aldehyde can be classified Aldehyde can be classified. Aldehyde can be classified into aldehyde. Aldehyde can be classified into. So aldehyde can be classified into three, which are the aliphatic aldehydes. Aldehydes can be classified into three: simple aldehyde or aliphatic aldehyde. Simple aldehyde, or you can say aliphatic aldehyde. So simple aldehyde, simple aldehyde, or you can say aliphatic aldehydes. The next one is alicyclic aldehyde. What do you mean by alicyclic aldehyde? Ring compound is called alicyclic aldehyde. So ring compound is called alicyclic aldehyde. That is this type of compound is called alicyclic aldehyde. And the third one is aromatic aldehyde. Aromatic aldehyde. And third one is aromatic aldehyde. Aromatic aldehyde can be of two types. First one is if the benzene ring is directly attached to the CHO group. If the benzene ring is directly attached to the CHO group, it is called benzaldehyde. It is called benzaldehyde. Benzaldehyde. Next type of aldehyde is if the aldehyde is attached to the benzene ring as a side chain. As a side chain, then the side chain is considered as the main chain. So this is the side chain that is considered as the main chain. Side chain that is considered as the main chain. Main chain. So this group is considered as the substituent. That is, it is called phenyl. Phenyl. What we call phenyl. So aldehyde can be classified into simple aldehyde, alicyclic aldehyde, aromatic aldehyde. If it is simple aldehyde, the IUPAC naming will be, if it is simple aldehyde, the IUPAC naming will be alkanal. 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 If it is alicyclic compound, then it is called cyclo cycloalkane cycloalkane carbaldehyde. Cycloalkane carbaldehyde. Cycloalkane carbaldehyde. Cycloalkane carbaldehyde. So we can discuss it in a detail. First we are taking aliphatic 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 aldehyde. So first one is aliphatic aldehyde. Aliphatic aldehyde. Aliphatic aldehyde. So what will be the IUPAC naming of this compound? CS3CHO. HCHO. What will be the common name of first one? This is the first one. This is the first one. This is the second one. So what will be the common name of first one? The common name will be formaldehyde. Common name will be formaldehyde. What will be the IUPAC name? What will be the IUPAC name? How many carbon atom are here? How many carbon atom are here? Only one carbon atom. For one carbon atom, we say it is methanol. So it is methanol. Methanol. So what will be the common name of this compound? Acetaldehyde. Is it? So it is acetaldehyde. Acetaldehyde. How many carbon atom? F. If it is aldehyde, we use Al. Al. So it is ethanol. Ethanol. Is that clear? Is that clear for you? So another compound. The another compound is third one. CH3, CH2, CH2, CH, Br, CHO. So the number should be started from the carbon atom of the aldehyde. So the number will 1. CHO 1. It is 2, 3, 4, 5. So on the second position, there is a substituent that is bromo. 2 bromo, 2 bromo, 2 bromo, 2 bromo, 2 bromo pentane, 2 bromo, 2 bromo. If it is aldehyde, we'll take it as al. So it is 2 bromo pentanol. Is that clear? Is that clear for you? So on moving to the next one is alicyclic aldehyde. So what is alicyclic aldehyde? What is alicyclic aldehyde? What is alicyclic aldehyde? The compound containing a ring is called alicyclic aldehyde. Alicyclic aldehyde. Alicyclic aldehyde. Alicyclic aldehyde. So, if it is alicyclic compound, what will be the IUPAC naming? Comment on the comment box. What will be the IUPAC name of alicyclic compound? Comment first. So it is cycloalkane carbaldehyde. So it is cycloalkane carbaldehyde. Cycloalkane carbaldehyde. Cycloalkane carbaldehyde. So, what will be the UPC name of this compound? What will be the UPC name of this compound? If you know, comment on the comment box. So, you have to count the number of carbon atom. How many number of carbon are here? 1, 2, 3, 4, 5. So it is pentane. So the IUPAC name will be cyclopentane, cyclopentane, cyclopentane carbaldehyde, cyclopentane, cyclopentane carbaldehyde, carbaldehyde, cyclopentane carbaldehyde. So another one is benzene, that is attached to cyclobenzene, cyclohexane, that is attached to the, what will be the UPC name of this compound? It is how many carbon atom? 1, 2, 3, 4, 5, 6. So it is cyclohexane carbaldehyde, cyclohexane carbaldehyde. And the third, this is second example, and the third example is, third example is if it is an NO2 group is attached to the ring, what will be the UPC name? So it will be, count the number of carbon atom. You already know it is 6 carbon atom, is it? So on the first, 2, 3. On the third position, there is a nitro group. So it is 3 nitro, 3 nitro, 3 nitro, cyclo, 3 nitro cyclohexane carbaldehyde, carbaldehyde. I think this is clear for you. First we study simple aldehyde, then we study alicyclic aldehyde, then we are going to study the IUPAC name of aromatic aldehyde. What is aromatic aldehyde? If aromatic aldehyde are of two types, if we are attaching the benzene ring directly to the if we are adding benzene ring directly to the aldehyde, it is called benzaldehyde. So if we are if the benzene ring is attached directly to the CHO group, it is called benzaldehyde. It is called benzaldehyde. Benzaldehyde. If the Then tell me, what is the IUPAC name of this compound? CHO CH3. What it is? CH3? CH3? CH3 is methyl. In which position is methyl group is attached? Methyl group is attached on the third position. So it is 3 methyl. You already know that benzene ring containing CHO group is benzaldehyde. So there is a methyl substituent. You only have to indicate the position of that 3 methyl 3 methyl benzaldehyde. 3 methyl benzaldehyde. 3 methyl benzaldehyde. Instead of CH3 group, suppose if here a nitro group is Instead of CSA, if there is a nitro group, then it is called, what will be the IUPAC name of this compound? NO2, nitro group. So the formula of nitro group is what? You have to say what is the formula of nitro group. So nitro group means NO2 group. So if a NO2 group is attached to, if an NO2 group is attached to the benzene ring, then it is called nitro. So it is 3 nitro. Which position that nitro group is attached? On third position. So it is 3 nitro benzaldehyde. 3 nitro, 3 nitro benzaldehyde. And the next one is CHO. What will be the IUPAC name of this compound? In which position the CH3 group is come? On the in the second position. So it will be 2-methyl, 2-methyl, 3-nitro benzaldehyde. Is that clear? I hope the naming will be clear for you. The next we are moving to the naming of ketone. Next we are moving to the naming of ketone. Ketone Ketone also have a common name. The common name of ketone is alkyl ketone. The common name of ketone is alkyl ketone. So what will be the UPC name of this compound? So it is CH3, CHO, CH2, CH2, CH3. So you have to write on the alphabetical order. The first one will be ethyl. Is it ethyl propyl ketone? Ethyl propyl ketone. Ethyl propyl ketone. The IUPAC naming will be, what will be the IUPAC naming? Here also aldehyde can be classified into 3, that is aliphatic or simple ketone, alicyclic ketone and aromatic ketone. Here also ketone can be classified into 3. Which are they? Which are they? Simple ketone, alicyclic ketone and aromatic ketone. If it is simple ketone, simple ketone, if it is simple ketone, its IUPAC naming will be alkanone. Alkanone. If it is simple ketone, its IUPAC naming will be alkanone. If it is alicyclic ketone, that means a ring compound, it is called alicyclic ketone. If it is alicyclic ketone, then it is called cycloalkanone. Cycloalkanone. Aromatic ketone is always come as a side chain. So the side chain is considered as the main chain. Side chain is considered as the main chain. So it is side chain. Side chain is considered as the main chain. Side chain is considered as the main chain. side chain is considered as the main chain. Is that clear? 4. If it is simple ketone, we named as alkanol. If it is alicyclic ketone, we name as cycloalkanol. If it is aromatic ketone, we say as side. We say the side chain is considered as the main chain, and this the phenyl, the aromatic compound is considered as the substituent, that is phenyl. So then it is called phenyl. Is that clear? Then we can practice the nomenclature of compounds. So the first one is aliphatic aliphatic ketone. So first one is CH3 CH3 CO CH3 CH3 CO CH3. So what will be the IUPAC name? It is an aliphatic ketone. So it is alkanol. So count the number of carbon atom. 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 So it is called, how many carbon atom are there? 3 carbon atom. So it is, how many number of carbon atom? 3 carbon atom. So it is 1, it is 1, 2 and 3. So it is 3 carbon atom, that is propanol. Propanol. So the naming will be propanol. What will be the common name of this compound, this ketone? So we already discussed that the common name of ketone is alkyl ketone. Is it? So there are 3. How many alkyl part? 2 alkyl part. So you can write this as the common name dimethyl ketone. Dimethyl ketone. The next example is CH3 CH2 C double bond O CH2 CH3. So what is the IUPAC name of this one? Count the number of carbon atom. 1, 2, 3, 4, 5. So it is 3 carbon atom. Here you have to indicate the position of the ketone also. It is propane. I said it is propane. It is propane. In which position the ketone? You have to indicate the position of the ketone. That is propane 2 O. So, how many number of carbon atom are there in this compound? 5. Is it? 5. So, it is for 5. It is pentane. Pentane. In which position the ketone group is? Ketone on the 3rd position. So, you have to indicate the position of the ketone. That is 3 ol. Pentane 3 ol. So, this is the name nomenclature of simple aldehyde. For simple aldehyde, we are using the IUPAC name alkanol. So, if it is an alicyclic ketone, the naming will be cycloalkanol. 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 Then tell me The IUPAC name of this compound. Tell me the IUPAC name of this one. How many number of carbon atom? One, two, three, four, five. So it is cyclo. How many carbon atom? One, two, three, four, five. So it will be cyclopentanone. Cyclopentanone. Next one. This one you have to say, you have to comment on the comment box. See it. Sorry. Okay, fine. What will be the IUPAC name of? I wrote it as aldehyde. I already teach that the nomenclature for alicyclic compound for aldehyde. So you can write this the IUPAC name of this one. What will be the IUPAC name of aldehyde? So it is an alicyclic aldehyde. You know what will be the IUPAC name of for alicyclic aldehyde? What will be the answer? It is cycloalkane carbaldehyde. I already told that cycloalkane carbaldehyde IUPAC name for is the IUPAC name for is the IUPAC name for aldehyde, alicyclic aldehyde. So what will be the name of this compound? It is cyclopentane carbaldehyde. Cyclopentane carbaldehyde. Is that clear? So suppose I change this CHO group. I change this CHO group. I change this CHO group to C double bond O. Then what will be the IUPAC name? What is the IUPAC name of this compound? It contains 6 number of carbon atom. So it is a cyclic compound. So what will be the IUPAC name? It is cyclohexane. It is cyclohex X hex hex. It is cyclohexane. No, ketone is here. Is that clear? Next, we are moving to the aromatic aldehyde. Aromatic aldehyde. Then we are moving to aromatic. Is it aldehyde or ketone? It is ketone. So it is aromatic ketone. So write the IUPAC name of this compound. C double bond O CH2 CH3. So you have the numbering should be started from here. So what will be the one? It is 1, 2, and 3. So it is 1 phenyl. It is 1 phenyl. 1 phenyl. How many carbon atoms? 3 carbon atoms. So it is 1 phenyl propane 1 on. You have to indicate the position of the ketone. So it is 1 phenyl propane 1 on. The next example for aromatic compound is penicillin containing C double bond O CH2 CH2 CH3. So what is the IUPAC name of this compound? So it is 1, 2, 3, 4. So it is 4. When it is 4 carbon atom, we call it bute, is it? So the phenyl group is considered as the substituent. When it is come as a substituent, we call it as phenyl. So it is 1 phenyl, it is 1 phenyl, butate, 1 on. Is that clear for you? So we study the nomenclature of aldehyde and ketone. For aldehyde, it can be classified into 3: simple aldehyde, alicyclic aldehyde, and aromatic aldehyde. If it is simple aldehyde, we call it as alkanol. And if it is alicyclic aldehyde, we call it as cycloalkane carbaldehyde. And aromatic aldehyde can be of two types. If it is directly attached to the CH group is directly attached to the benzene ring, then it is called benzaldehyde. And if it is considered, if it is come as a side chain, the side chain is considered as the main chain. So the phenyl group is considered as the substituent. Is that clear? Then we discuss about ketone. Ketone also classified into 3: simple ketone, alicyclic ketone, and aromatic ketone. Simple ketone we call it as simple ketone we call it as alkanol, and if it is alicyclic ketone it is called cycloalkanol. And the ketone is always come as a side chain. This side chain is considered as the main chain. I hope it is clear for you. Then we are moving to the structure of carbonyl group. You all know that carbon C double bond O is the carbonyl group. Is it? Whenever a carbon containing a pi bond, the carbon is have sp2 hybridized. The carbon is said to be sp2 hybridized carbon atom, and its shape will be trigonal planar. So here you can see the carbon attached to the atom is having 3 sigma bond. One here, and one here. So it has 3 sigma bond and 1 pi bond. So this is the carbon. The carbon is attached to an atom. Here one is here and one is here, and one is attached to the oxygen. So we can say that all are lay in the same plane. The unhybridized p orbital of the carbon is overlapped with the p orbital of oxygen, that is lay above and below the plane. So you can see the carbon is sp2 hybridized. Carbon is sp2 hybridized. It has 3 sigma and 1 pi bond. It has 3 sigma and 1 pi bond. In addition, the oxygen atom has 2 non-bonding electron pairs. There are 2 non-bonding electron pairs are on the oxygen atom. So the shape of this compound will be, what will be the shape? It will be triangular planar. It is like this. It is like a triangular planar. So all are laying on the same plane. So it has, in the carbonyl group, it has a planar symmetry, that is triangular planar symmetry, in which carbon along with the 3 atoms are attached to lie on the same plane. The pi electron are spread above and below the plane. So this is all about the structure of carbonyl group. First one is it is sp2 hybridized. Then the bond angle will, it is the shape of the carbonyl group is triangular planar, and the bond angle will be 120 degree. Bond angle will be 120 degree. It has 3 sigma bond and 1 pi bond. I hope everyone has clear. So next we are going to the preparation of aldehydes and ketones. So this preparation is for both aldehyde and ketones. So the first method of preparation for both aldehyde and ketone is oxidation of alcohols. What do you mean by oxidation? Oxidation is removal of hydrogen and addition of oxygen. Is it? So here the alcohol, if we are taking the primary alcohol will be oxidized to aldehyde, and if we are taking secondary alcohol, we get ketone. So here you all know that when aldehyde, we have to prepare aldehyde. Is it? We have to prepare aldehyde, RCHO. Here we are taking primary. If we are taking primary alcohol, RCO, RCH2OH, RCH2OH. So what do you mean by primary alcohol? How will you know it is primary, whether it is primary alcohol or secondary alcohol? If it is primary alcohol, the OH group attached to the carbon will attach only one alkyl group. So this is primary alcohol. So in this oxidation of alcohol, actually the CH bond, I will show that RCH, CHOH. Here actually CH bond, this CH bond and OH bond cleavage is occurring. CH and OH bond cleavage is occurring. So this dihydrogen will be eliminated. Then you will get corresponding aldehyde. Is that clear? So here on oxidation you will get aldehyde. Is it? This aldehyde on further oxidation you will get carboxylic acid, RCOH. You will get carboxylic acid. So we have to take mild oxidizing agent. Which are the mild oxidizing agent? PCC. You may heard about PCC. What is PCC? Pyridinum dichlorochromate. Pyridinum dichlorochromate. Then CrO3. These all are mild oxidizing agent. These are all are mild oxidizing agent. These are all are mild oxidizing agent. If you are taking a strong oxidizing agent like KMNO4, if you are taking strong oxidizing agent like KMNO4, that will directly convert it to acid. So we only need aldehyde. Is it? So we have to take mild oxidizing agent like PCC, CrO3. If we are taking PCC, we will get a good yield of aldehyde. We will get a good yield of aldehyde. So most commonly we are using PCC for the preparation of aldehyde. So I will give an example. CH3, CH2, OH. So this is an ethanol. Is it? This ethanol on treating with PCC. PCC. What is PCC? Pyridinum dichlorochromate. This PCC on oxidation, you will get this CH and OH bond cleavage will occur. So I will wrote like this: CH3, CH, OH. So cleave the cleave the CH bond, that is dihydrogen will be eliminated and you will get corresponding aldehyde remaining CH3 CHO. CH3 CHO. That is you will get ethanol. Ethanol. Is that clear? So if we are taking secondary alcohol, then tell me what is secondary alcohol? If the carbon atom of the OH group is attached to two alkyl group, then it is called secondary alcohol. So the secondary alcohol on treating with CrO3. Here also CH and OH bond will cleave and this will eliminate it. So you will get corresponding ketone. RC double bond O R. You will get ketone. So write the product of this compound CH3 CH CH3 OH. CrO3. So what will happen? Dihydrogen will be eliminated. So this group will be eliminated and you will get corresponding ketone. RC double, sorry, CH3, 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 C double bond O, CH3. So you will get propan 2-on. So the first method of preparation, I hope the first method of preparation is clear for you. And the second method of preparation is by dehydrogenation of alcohol. What do you mean by dehydrogenation? What do you mean by dehydration? Dehydration means remove the water molecule. So dehydrogenation means hydrogen will be removed. So here we are taking alcohol vapors. We are taking alcohol vapors. Alcohol vapors on heating with heavy metal catalysts like copper and silver, you will get corresponding aldehyde and ketone. If you are taking primary alcohol, then you will get aldehyde. If you are taking secondary alcohol, you will get ketone. So on CH2OH. Is it? This RCH2OH is treated with heavy metal like Cu at 573 Kelvin. You will get the corresponding aldehyde. Dihydrogen will be one hydrogen from this and the hydrogen will be eliminated and you will get RCHO. You will get RCHO will be obtained. So this is primary alcohol. If you are taking secondary alcohol, RCH, ROH in presence of copper at 573 Kelvin, remove the hydrogen and you will get RC double bond O R. Tertiary alcohols do not undergo dehydration reaction. Why? Tertiary alcohol do not undergo dehydration. So in tertiary alcohol, there are in tertiary alcohol there are three alkyl group attached to the carbon containing CO2 group. Is it? So this is tertiary. This is tertiary. This is tertiary alcohol. So I told you there is no CH cleavage cannot occur on this tertiary alcohol. So we will get alkene. One hydrogen from here will be eliminated. One hydrogen from this carbon will be eliminated, and this eliminated as water molecule, and the bond will shifted to this carbon atom. We will get corresponding alkene will be obtained. Alkene will be obtained. CH2, CH3. So since we have to prepare aldehyde ketone, is it? So tertiary alcohols cannot prepare aldehyde ketone. Okay, the next one is from hydrocarbon. So hydrocarbon, there are two methods. First method is by the ozone lysis of alkene. What do you mean by lysis? Lysis means breaking or cleavage. Cleavage of alkene. Cleavage of double bond by using ozone is called ozone lysis. By the breaking of ozone by using alkene. So ozonolysis means breaking of alkene by using ozone. So here ozonolysis of alkene followed by a reaction with zinc dust in water which gives aldehyde and ketone. Is that clear? So here CH3, CH double bond CH, CH3. So here lysis means breaking the bond, breaking the bond, break this bond in the presence of ozone, breaking the bond of alkene by ozone in presence of zinc dust and water. First you get ozonate. So CH3, CH3, CH, CH, CH3. So peroxide formation will occur. So clean this bond, clean this bond, clean this bond, you will get CH3, you will get CH3, CHO, CH3, CHO. You will get two molecule of acetaldehyde. Is that clear? So here you can use simple technique. Here you can use simple technique to get the product. Just add O here. Just add two molecule of oxygen here. Then you will get the final product, that is CH3, CHO plus CH3, CHO. Is that clear? Then one more method in this reaction is by the hydration of alkane. So here alkyl is hydrating. That means here the alkyl part, it is C triple bond CH3. First we are taking CH triple bond CH, that is ethine. Ethine on treating with water in presence of sulfuric acid. In presence of sulfuric acid or mercuric sulfate AgSO4. First you will get enol form. So that is this hydrogen will shift to the carbon and the bond will break first. The multiple bond will break and this OH will attach to the carbon. So you will get CH, CH, H, double bond CH, OH. So here actually tautomerism occur. That is, this hydrogen will shift to this hydrogen will shift to this carbon and this double bond will shift to this. And you will get CH3, CH3, CHO, CH3, CHO. So you will get CH3, CHO. What is CH3, CHO? Acetaldehyde, or you can say ethanol. Acetaldehyde or ethanol. So if you are taking ethane, you will get acetaldehyde. Is it? If you are taking any other alkane, you will get ketone. That is, if you are taking CH3, CH3, CH triple bond C CH CH CH3 C triple bond CH, then you will get that on hydration, what you get? So we are hydrating this one. So hydrating, on hydration you get the hydrogen atom. The negative part of the OH will go to the negative part of the oxygen OH group will go to the negative part of the oxygen atom will go to the carbon containing less number of hydrogen atom. This is based on which rule? Can you say? This is based on Markovnikov rule. So the negative OH group will go to the carbon containing less number of hydrogen atom and this hydrogen will be attached to the CH. So it will be in the presence of H2SO4 and AgSO4. So what you get? What you get? CH3, CH3, COH, CH2. So here also tautomerism will occur. Tautomerism will occur. This hydrogen will be shifted to this carbon atom and this bond will shifted to this carbon atom. Then you will get CH3 C double bond O CH3. So you will get ketone. What do you get? Ketone. So alkane, ethane, only ethane you will get as aldehyde. All other alkane you will get ketone. Is that clear? So this is the method of preparation. These are the method of preparation for both. These are the method of preparation for both aldehyde and ketone. So first method is by the oxidation of alcohol. By the oxidation of alcohol, you will get primary. If you are using primary alcohol, you will get aldehyde. If you are using secondary alcohol, you will get ketone. And the next method is by the dehydration of alcohol. by the dehydrogenation of alcohol. Dehydrogenation means removal of hydrogen. Here also the alcohol is passed over heavy metal like silver, copper. When it is heated at 573, when copper is heated at 573 Kelvin, you will get aldehyde. If you are taking primary alcohol, you will get corresponding aldehyde. If you are taking secondary alcohol, you will get ketone. And the next method is from hydrocarbon. From hydrocarbon, first method is by the ozone lysis of alkene. By the ozone lysis of alkene. What do you mean by ozone lysis? Means breaking of alkene, breaking of double bond by using ozone. So if this reaction is carried out in the presence of zinc, dust and water, you will get corresponding aldehyde and ketone. And the next one is by the hydration of alkane. So the hydration of alkane is that addition of water. Addition of water. If you are taking ethyl, addition of water in presence of sulfuric acid and mercuric sulfate, you will get acetaldehyde. You will get acetaldehyde. All other alkane will give ketone. I hope everyone has clear this topic. And on Wednesday, your Satin sir is coming with this chapter 7, part 2. Part 2. So don't miss the class. Don't miss the class. Wait, he is coming with the part 2 of chapter 7, integral. So don't miss the class. Stay with us. Okay.